In this video, we're going to go over Math 4 quiz number 11 on probability. Number 1 says Mr. Gilmore surveyed his class to find out how many books each student read over the summer. He compiled his data and created this table. A says find the probability of having read 3 books. So if you just look at the probability distribution table, you can see that 3 books, the probability would be the 0.3. So that's all we need to answer A. Find the probability of having read at least 1 book. So at least 1 book means 1, 2, 3, or 4 books. So you just have to add up those probabilities. Or you could notice that 0.3 is the only one not included. So you could say 1 minus 0.3 and get 0.7, which you would get the same thing if you added all of these together with your calculator. So the answer to part B is 0.7. And then C says find the probability that X is greater than 2. So X in this case is number of books read over the summer. So the probability that that is greater than 2 is 3 and 4, because that would be the 2 numbers that are greater than 2. So if you add up 0.3 and 0.1, you get 0.4 for answer C. D says explain what Px is greater than 2 means. So that is asking you in very simple math symbols, what is the probability? Because that's what the P stands for. So what is the probability a student read, and it's greater than 2? So you could say more than or greater than, but normally we say something like more than 2 books over the summer, because the X represents whatever the thing is that you're finding the probability for. The P is probability, and then the symbol greater than needs to be written in language like more than, because we normally don't say greater than in our everyday language. All right, so that's it for number 1. Number 2 says in July in Portland, the grass grows a ½ inch a day on a sunny day and a ¼ inch a day on a cloudy day. In Portland in July, 75% of the days are sunny and 25% are cloudy. Find the expected amount of grass growth on a typical day in July in Portland. So if I set up a probability distribution, I want to think of what would happen and what's the probability of that happening. And so if the grass grows a ½ inch and that's on a sunny day, then I need to put the probability that goes with sunny. So 75% of the days are sunny. So I would put 0.75 since my calculator doesn't do percentages. And then it grows a ¼ inch on days that are cloudy, and that's a 25% chance that it's cloudy. So that's how I set up my probability distribution. And then I find the expected value by taking the 1/2 times the probability of 0.75 plus 1/4 times the probability of 0.25. And then I just need to calculate that. So let's do 1/2 times 0.75 plus 1/4 times 0.75. And we get, or excuse me, 0.25. Let me fix that number to be the right one. Okay, so then that would be 0.4375. And since we're talking about inches of grass, you can just leave it as that number. You don't need to convert it to anything else. So that's it for number 2. 3 says a tennis player makes a successful serve 85% of the time. So the probability that they can make that serve is 85%. Assume that each serve is independent of the others. If she serves 7 times, find the following probabilities. The probability that she gets exactly 1 serve in. So this is a binomial distribution because she either gets the serve in or she doesn't. There's an equal likelihood of her getting every serve in, and then they're independent of each other. And so we got to type in our calculator binom PDF because it's exactly 1. We need the PDF for those. The number of trials are the number of serves. So that was 7. There's an 85% chance to put 0.85, and then exactly 1, our last number would just be 1. So we hit second vars, which is our distribution menu on the calculator. Go to binom PDF and then type 7 for number of trials. Whoa, hold on. I typed something my calculator didn't like, so let me try that again. So second vars, binom PDF. We need number of trials. And then on my calculator, I put a comma, but on yours, I think it's a list. So you would type 7.85 and 1. And then you get this really small number, which I didn't mean for you to have such a small number, but it's just scientific notation. That means if you move your decimal over 5 places to the left, so 1, 2, 3, 4, 5, that would be where your decimal would fall. And so 0.000677 is really the number they're talking about. But like I say, I did not mean for that number to be so tiny and be in scientific notation. So if you got the number basically right, and I could tell you typed it in the calculator right, I gave you credit. But that is the actual answer, the way it should be written. So like either one, like this way is scientific notation, and then that means the same thing. All right, the second part says the probability that she gets all 7 in, which is still an exact amount, so you can type basically the same thing with a 7. So second vars again, get binom PDF. You had 7 trials. The probability is still 85%, so put 0.85. But now she wants all 7 serves. And so that probability is obviously lower because that would be less likely to happen. So I typed 7.85 and 7. And I got 0.32. And you can just leave it like that. If you wanted to make it a percentage, it would be 32%. And then number 4 says, a tennis player makes a successful serve 85% of the time. Assume that each serve is independent of the others. If she serves 7 times, find the following probability. So it's the same situation with the tennis player. But now we want the probability that she gets at least 3 serves in. So at least 3. So what I like to do is think of all the numbers possible to think of what I need to tell my calculator. So if there's 1, 2, 3, 4, 5, 6, 7 serves, and she wants the probability that she gets at least 3 in. She wants the probability of 3, 4, 5, 6, or 7. So you have to tell your calculator to subtract out the probability of the ones that come first. So 1 minus binom CDF. And we still have the same number of trials, which was 7 serves. The 85% is still the same probability. But then we're subtracting out the probability of the 1 or 2 serves. And you're going to be left with the probability of 3, 4, 5, 6, or 7, which is what we want. So 1 minus, and then second vars would be binom CDF this time. And then we have 7, comma, 0.85, comma, 2. And we get 0.998 for that probability. And you can leave it like that, or you can put it as a percent, which would be 99.8%. So I'll just put that, because some of you wrote it that way. Okay, but either one is fine. The probability that she gets no more than 4 serves in. So if you think of no more than 4, means it includes the 4, but we want the probability of 1, 2, 3, and 4, like all those probabilities would be possible if she gets no more than 4. And since those are on the lower end of our numbers, we don't have to do 1 minus. We could just do binom CDF, and then 7.85, and 4 would be the last number because you want to include it. So second vars binom CDF, 7, comma, 0.85, comma, 4. And we get 0.074, or you could say that's 7.4%. Okay, so that's it for number 4. Number 5 says a grading scale is set up for 900 students' test scores. It is assumed that the scores are normally distributed with a mean score of 65 and a standard deviation of 10. How many students will have scores higher than 50? So notice they're not asking you for probability, they're asking you for number of students. But we do need to get the probability in order to find our number of students. So what we do first is go to Desmos, and we go to the functions menu and go down to distributions, probability distributions, and then you find the normal dist option. So for part A, I want to type in the 65 is my mean, comma, and then I need my standard deviation of 10. And then for the first option, it's higher than 50. So 50 is your lowest amount and you want to leave the upper end open, so that's infinity. And I get 0.933. But if they want to know the number of students, you've got to multiply that probability times the 900 students to get the number of students. So I could just use my calculator right here. 0.933 times 900 would give me 839.7. So I need to round to the nearest like whole student. So it'd be 840 students for part A. Part B says, how many students will score between 55 and 60? So leave those same numbers, but just type 55 to 60 for those cumulative probability numbers. And we get 0.15, so there's a 15% chance, but we got to multiply by the 900 to figure out the number of students. So 0.15 times 900 gives us 135 students. And for the last part, how many students will have scores below 85? So below 85 means 85 would be your upper limit, and that would be 0.977. And again, they want the number of students. So just multiply that by the 900 to get the number of students. So I will say that's about 879 students. So for your test coming up on Monday, just be careful that if it asks for like number of students, number of chickens, like whatever it's asking you for, then you need to multiply by the number after you find the probability. But if it's not asking for that and it just wants the probability, then you just leave the probability the way you find it from normal dist in Desmos. But that is it for quiz number 11.